So now that we have defined our chemicals, the mixtures and the parameters that we will be using to make the recipe for this library, then we can go to the recipe tab to create the recipe we want to use for the library. So for example, I'm going to dispense the preservative premix solution into the array 4x6 array. So to do that, you basically click on the preservative mix, and then you have two choices. You can basically drop it on one of the well of the library and then highlight the ones that you want to apply this preservative mix to, or if you want to apply this to the entire library, there's a simpler way where you go to this tab at the top left corner and then you click on it. It will basically select the entire library. So now once you selected the entire library to dispense this particular preservative mix that you have defined in your chemical mixture, you have many options to map the volume you want to dispense into the library. The simplest option is uniform. So here you can define a number, and that would be uniformly distributed in all the well. And you have other options, for example, discrete amount, where as you can see here, the table will open up and you can put discrete amount of volume, or for that matter, you can choose the dispense unit from the drop-down list, and you can put a discrete amount of liquid into the different library wells. Then you also have choice to choose gradient. So once you choose the gradient, you can define the direction of the gradient, left to right or right to left, top to bottom, etc. And then you can define what's the minimum amount to start the gradient with, and then the maximum amount and the step size. So for example, here say I choose minimum amount as 10 microliter, maximum amount say 100 microliter, and step size of 1, and you can see in the bottom view that how this amount would be distributed from left to right, because you have chosen the direction left to right. Also you can choose the step size as 1 or 2. As you can see here, say in a library you want to run say replicates, the two same conditions, then you can choose the step size to be 2, and then it will choose like 2 well with same concentration. Also you have a choice here to define the shape of the curve. Here you can see as you change the number, the shape of the linear gradient is going to change. And you can see here the last option in this window is the tag, and tag is the information that is shared to the Automation Studio as to what to be done with this particular map. For example, whether this is a map for dispensing liquid. So once you say it's a processing or some tag, that would be read by the Automation Studio, and it will know that it has to dispense this particular chemical from the chemical source position defined there into this particular library. So another option from the drop-down list is geometric, where you can, as you can see here, similar to the gradient, you can define the starting amount, say 10 microliter, and then the increased in the percentage from one well to the next well, and then again the step size. And you can see in the bottom window how the amount would be varied from left to right, as we have chosen left to right direction. So other option we have is known as exist. So exist is usually used when the volume is calculated through a set of equations, and I'm going to show you how to set up this equation next. To explain how to define the map with the tag exist from a set of equations, I'm going to use a pre-existing library design. So this is a library design for a lotion where we have defined the chemicals, mixtures, parameters, and I'm on the recipe tab. And here I'll show how you can basically apply formulas to a library and then use exist for dispensing chemicals. For example, you can choose a particular the icon called formula and then apply it to the whole library or the selected wells in the library as I explained before, and then you can choose to write down the formula in this window. So I'm going to show you the existing formula. For example, I'll take this map which says that the total mass of all the liquid that's dispensed into the well should be 40,000 milligrams. And then the next map here says, say I'll choose the stearic acid. Here it says that the stearic acid, that's the volume, the amount of stearic acid in milligram in the well, should be 2.92% of the total mass. So similarly, here we have defined the other components that goes into the formulation, like the wax, the sweet almond oil, shea butter, and we have defined the total mass. So as you can see here, that out of 5 components that we are dispensing, the 4 components, the percentages has been predefined. So here so the rest of the chemical that will go to the well would be the balance amount of this particular vial that we are using. So if you look at the maps for each chemicals that has been used here to be dispensed into this library design, you can see we used exists, because the amount that would be dispensed is calculated by this set of 5 equations that we have defined. So these functions and set of equations and defining the map as exist is a very powerful tool to have a set of equations, predefined equations, to determine the amount of chemicals that you would like to dispense into the library wells, as you can see from this particular example. So this is an example of how the recipe would look at the end, and this is a recipe for a lotion, and you can see that we defined 2 different libraries here. One is a library for premix, and the other is the library where you are dispensing other liquids and the premix to make the final formulation. So here we have defined equation group. So that means that this set of equations would be applicable to all the chemicals within this group. So so here you can see the first, if you highlight the first step in the recipe, where we are setting the temperature to this particular well to 80 degrees, then we are setting the stir speed, and then we are adding different chemicals based on the set of equations that we have defined into that particular well, and then we are waiting for a specified amount of time for it to mix well, and then we are reducing the stir speed to 100 RPM. So at this point the premix is already set, and then we are using the second equation group to dispense various liquids into this 4x6 array of library. So it starts with, so we are only using the 6 well. As you can see, the temperature is set to uniform because it's the same temperature in all 6 position. Then we are setting the blending rate, and then adding water and other chemicals as we have defined before, based on the set of equation which are defined at the end for this particular library design. Also, when we are working with the recipe, we can remove the chemicals from the selected wells in the library by using the icon remove chemical or type. So to do that, we choose remove chemical, and then as we select the wells, we just go there and select all the wells that we want a particular chemical to be removed. And then in this window, as you can see, it'll going to give all the possible chemicals that you can remove based on this library design. And I per se want to remove the water, and I can either remove all water, so that will basically remove everything in that well, or I could choose to remove a particular allocate. So say I choose just remove 500 microliter of water, and if I say OK, so then it's going to remove 500 microliter of water from those selected library wells. There is one more feature in the Library Studio which allow you to map dispensers from one library to the another. So for example, I can choose the icon, say the library premix, and choose the source position, and then I can choose a destination cells. It could be any, say for example this 4, and then I can say dispense 500 microliters, and it's going to map the premix to this 4 selected well on the formulation plate. And this is an example where you can prepare a premix. For this particular case, it's a wax formulation which you basically pre-made, and then you can dispense from that plate to your actual formulation plate by many-to-many mapping.